To get a better idea of how ground-based instruments and sounding rockets are used, let's visit Professor Alv Egeland at the Andoya Rocket Range.
But before we visit Professor Egeland and learn more about the rocket range, let's review the two math concepts for today's program: data analysis and measurement. Data analysis and measurement are two important math concepts to scientists and engineers. You see, before things can be analyzed, they must first be measured. Scientists and engineers take measurements so they can collect data. Think about what you measure every day: length, volume, mass, or temperature, to name a few. Once scientists and engineers collect the data they need, then they must analyze that data. Scientists are constantly on the lookout for patterns that can help them understand how things work. By analyzing data, they can construct relationships among numbers and the scientific principles they are investigating. Now that you understand the importance of data analysis and measurement, let's go meet with Professor Alv Egeland.
How is a magnetometer used to measure auroral activity?
In analyzing the graph, what indicates a great disturbance in the Earth's magnetic field?
How are sounding rockets useful to scientists and engineers?
Professor Egeland, how are you?
Fine, thank you. How are you, Jennifer?
I'm wonderful, I'm wonderful. This is Dr. Odenwald.
Hello, Professor.
Hello, Dr. Odenwald. Nice to meet you.
Good to meet you, too.
You know, the Andoya Rocket Range is an exciting facility. Can you tell us some more about it?
Andoya Rocket Range is the furthest north permanent located rocket range where we launch rocket and scientific balloons. It's located here because it's just under the Aurora belt. And this is the place where we do all the launching of rocket and balloons from Norway. The range provides complete services for launch, operation, data acquisition, recovery, and ground instrumented support. Since 1962, more than 800 rockets have been launched from this range. We have also hosted scientists and engineers from more than 70 institutes and universities around the world.
Professor, what kind of ground-based measurements do you take here at the range?
Well, we take a lot of different measurements, but I think the most important is the recording of the Earth's magnetic field, and for that type of recordings we use a magnetometer.
A magnetometer. Sounds like an instrument that measures magnets or maybe a magnetic field?
You are on the right track, Jennifer. A magnetometer can be used to measure weak, short-term variation in the strength of the Earth's geomagnetic field. It was first used in the year 1800 by Alexander von Humboldt to study aurora and what he called magnetic storms. These variations are due to electric currents in the upper atmosphere. The electrons and ions flowing in from distant regions of the Earth's magnetic field cause currents to flow in the ionosphere and also cause the aurora currents. So a magnetometer measures a quantity that is directly related to the northern lights. The stronger the magnetic variation, the higher the auroral activity.
Professor, this is just one type of magnetometer, correct?
That's correct, yes.
Now, how do you analyze the data that you collect from a magnetometer?
What we do is really we reproduce some graphic representation. And if there is a big deviation from the local standard field, we call the magnetic storm. And I just want to show you one example here of a big magnetic storm. And here you can really see big deviation from the local standard field. The following graph shows a relatively weak magnetic storm. The magnetometer measures the geomagnetic field along three axes: north-south or H component, east-west or D component, and up-down or Z component. This graph is a magnetic field strength versus time plot. Now here is a plot of a relatively strong magnetic storm, probably caused by a disturbance in the solar wind. What can we conclude from the two graphs?
Let me see. The second graph shows more magnetic activity than the first graph. So I would say the more magnetic activity, the greater the auroral activity.
That's correct, Jennifer. Notice in this section of the graph, the deviations are at the maximum. If the night sky was clear, we can view the mysterious and beautiful aurora colors. Magnetometers located here at the range are continuously taking measurements of the local geomagnetic field. In fact, anyone from around the world can visit the following website to analyze the geomagnetic activity around the Aurora rocket range.
Professor, you mentioned that this facility is known for auroral research using sounding rockets.
Yes, that's correct. As a matter of fact, that's the main purpose for the rocket range. We can study the aurora from the ground, but then we just look on the bottom aurora. If you study the aurora from a satellite, you just study the top of the aurora. But by using instrumented rocket, you can study the inside of the aurora. That's why sounding rocket is such a unique platform for auroral studies. Other instruments on the rocket register electric field and magnetic field and count particles coming into the atmosphere from distant part of the Earth's magnetic field. Consequently, the energy that produces the northern light can be calculated. During an ordinary winter night in Norway, the northern light involves more energy than the country uses in 1 year. A severe auroral storm can produce billions of joules of energy per second.
Professor Eglund, thank you. We learned so much.
It's really my pleasure. Thank you too. Or as we say in Norway, gleden var på min side.
Okay guys, now it's time for a cue card review. How is a magnetometer used to measure auroral activity? In analyzing the graph, what indicates a great disturbance in the Earth's magnetic field? How are sounding rockets useful to scientists and engineers? So, did you get all the answers to the questions? Good. Now, let's review. We've learned about the myths and legends surrounding the Northern Lights, and we also learned how ground-based instruments and sounding rockets are used to study the auroras. Now, we turn our focus to space. Later in the program, Dr. Nikki Fox will tell us how data analysis and measurement are used to study the auroras with the help of 2 NASA satellites, Polar and Timed. But first, Sten will give us the scoop on image.